Hello students, in the previous session we had discussed about the definition of Laplace transform and also we derived the basic standard formulas of Laplace transform. There are totally 7 basic standard formulas of Laplace transform. First one we did L of 1 equal to 1 by S. Second, L of e raised to at equal to 1 divided by s minus a. Third one, L of t raised to n equal to n factorial divided by s raised to n plus 1. Fourth one, L of sin at equal to a divided by s square plus a square. Fifth one, L of cos at equal to s divided by s square plus a square. Sixth one, L of sin h at hyperbolic function a divided by s square minus a square. And last one, seventh one, L of cos h at s divided by s square minus a square. Now in this session we will do the properties of Laplace transform. Now the first property is linearity property. Now what is this linearity property? First one, linearity property. In the linearity property we take the constant outside the Laplace transform operator, that is if L of f of t is equal to f of s and L of g of t equal to g of s, then L of C1 is constant, f of t plus C2 another constant, second function g of t is equal to C1 L of f of t plus C2 second term L of g of t. This is the first fundamental properties. If the function is multiplied by some constant, we can take the constant outside the Laplace transform operator, and proof is very simple. Just by using the definition of Laplace transform we will get the required result. Second property, the first shifting property. Now what is this first shifting property? First shifting property. Now if L of f of t is equal to f of s, and if the function f of t, if the function is f of t is multiplied by e raised to at, if the function is multiplied by e raised to at, if you take its Laplace transform, then s changes to s minus a. If the function f of t is multiplied by the exponential function e raised to at, if take its Laplace transform, s changes to s minus a, f of s minus a. Now this one proof also it is very simple, just by using the definition of Laplace transform only, and by using this first shifting property again we have the 5 standard formulas. Basically, the standard formulas in the Laplace term, totally there are 7, and again by using this first property we have the again another 5 standard formulas. 5 standard formulas, that is first one L of e raised to a t equal to t raised to n, that is n factorial divided by s minus a whole to the power of n. We know the formula L of t raised to n, L of t raised to n, it is n factorial divided by s raised to n plus 1. Now, if the function, this is the function f of t, if it is multiplied by the exponential function e raised to a t, if you take its Laplace transform, as I told, s changes to s minus a, it is n factorial divided by s minus a whole to the power of n plus 1. It is here f of s is your n factorial by s raised to n plus 1, where the function is multiplied by the exponential, and if you take its Laplace transform, now s n factorial as it is, now s changes to s minus a whole to the power of n plus 1. Now, similarly, if you consider the L of sin b t, this is b divided by s square plus b square. Now, if sin b t function is multiplied by the exponential function, if you take its Laplace transform L of e raised to a t sin b t, it is b divided by s minus a whole square plus b square. This is the second formula. Similarly, the third standard formula L of cos b t. What is L of cos b t? As we derived, this is b divided by s square plus b square. Now, here if you consider cos b t as the function, and if you multiplied by the exponential function, then s changes to, this is s divided by s square plus b square, it is s minus a divided by s minus a whole square plus b square. Similarly, the fourth one for hyperbolic function, if you consider the hyperbolic function L of sin h b t, this is b divided by s square minus b square. Now, function sin b t, if it is multiplied by the exponential function, and if you take its Laplace transform, now s changes to s minus a whole square plus b square. Now, s changes to s minus a. Similarly, the last one, the hyperbolic function cos h b t, it is s divided by s square minus b square. Now, the function is cos h b t. If you take the exponential function e raised to a t, and if you take its Laplace transform, now s changes to s minus a. How will write? S minus a divided by s minus a whole square. Sorry, this is minus b square. This is also minus b square. S changes to s minus a. These are the 5 standard formula by using the first shifting property. Now, easily we can able to identify this property, when the function is multiplied by the exponential function. Now s, if you take its Laplace transform, then s changes to s minus a, f of s minus a. Now we will do the some of the examples based on the first shifting property. What is the, find the Laplace transform for the following functions. First one e raised to 2t sin square 3t. Second one e raised to minus 2t cos cube 2t. Third one e raised to 3t sin 4t into cos 3t. Now we will do the first example. Now the first example, you have to find the Laplace transform of e raised to 2t sin square 3t. You have to find the Laplace transform. Now here it is a product of two function and one of the function is exponential. Here you have to use the first shifting property. How to find the solution? Let e raised to 2t sin square 3t is equal to e raised to 8t f of t. Then what is your function f of t? What is your function? Here f of t is trigonometric function sin square 3t. And what is the exponential function? E raised to 8t. Then a is 2 here. A is 2. Now for the function f of t, first you have to find the Laplace transform. Now how to find the Laplace transform of the function f of t? That is L of f of t is equal to L of sin square 3t. How will find Laplace transform of sin square 3t? Here it is, the function is trigonometric function. You have to use the corresponding trigonometric formula. What is sin square theta formula? You must know the formula, basic formulas, trigonometry. Sin square theta 1 minus cos 2 theta by 2. Now we can write by using the formula sin square theta. Theta is 3t here. 1 minus cos 2 into 3t divided by 2. Now this is 1 by 2 is constant, denominator 2 is constant. By using the linearity property, first fundamental property, you can take the constant outside the operator, that is L of 1 minus cos 6t, 2 into 3t cos 6t. Now it reduced to, given function reduces to the standard form. First term L of 1 is 1 by, yes, basic standard formula, first formula L of 1 minus L of cos 60, L of cos 80, A is a 6, S divided by S square plus 6 square. Now this is your f of s. L of f of t is equal to f of s. Now you have to use the definition or the property of first shifting property. Now if you consider the property by first shifting property L of e raised to at f of t equal to f of s minus a, f of s minus a. Now here if you substitute the corresponding value L of e raised to 2t f of t over sin square 3t, sin square 3t. Now RHS s changes to s minus, this is your f of s. Now s changes to s minus, what is your a is 2, s changes to s minus 2. Therefore, how will write? Therefore, L of e raised to 2t sin square 3t is equal to, now this is your f of s, this is f of s minus 2. Now s changes to, you have to write it as s minus 2. Now this is 1 by 2, 1 divided by s minus 2 minus s minus 2 divided by s minus 2 whole square plus 6 square. Now like this you have to do the problem. Whenever the function is multiplied by the exponential function, it is you have to use the first shifting property formula. Now this is we did by using sin square theta. Similarly you can do if it is cos square 3t, if it is instead of sin square 3t, sin square 3t, if it is cos square 3t, then you have to use the cos square theta formula. What is cos square theta? 1 plus cos 2 theta by 2. If it is in place of sin as cos is there, you have to use the cos square theta formula, 1 plus cos 2 theta by 2. Okay, now we will go to the second example. Second example is, second one, you have to find the Laplace transform of e raised to minus 2t. What is cos cube 2t, cos cube 2t. Then how to find its Laplace transform? If you consider e raised to minus 2t cos cube 2t, then your is equal to e raised to at f of t, e raised to at f of t, e raised to at f of t. Then what is your function? Trigonometric function cos cube 2t. And what is your a? E raised to at, e raised to at is minus 2. Now if you, then you have to find the Laplace transform of the function L of f of t equal to L of cos cube 2t. Now here the function is trigonometric function and it is not in the standard form. You have to write in the standard form. How you are writing in the standard form? By using the corresponding trigonometric formula. It is cos cube theta. What is cos cube theta formula? 3 cos theta. You must know the basic formulas. Cos cube theta, 3 cos theta, what is plus cos 3 theta divided by 4. Now you can, by using this formula, you can write 3 cos 2t. Theta is here 2t plus cos 3 into 2t whole divided by 4. Whole divided by 4. Now you can write, take the constant outside the operator. 1 by 4 is constant. You can take it outside. L of 3 cos 2t plus cos 6t. Now the given function reduces to the standard form, you can apply the corresponding Laplace transform formulas. Now 1 by 4 you can keep it as it is, then 3 is constant, L of cos 2t, it is L of cos 80, A is 2 here, S divided by S square plus 2 square plus L of second term cos 80, here cos 60, A is 6 here, S divided by S square plus 6 square. Now this is your f of s, L of f of t is f of s. Now use the first shifting property. By the first shifting property, L of e raised to at f of t is equal to f of s minus a, that is L of e raised to minus 2t cos cube 2t is equal to f of s. A is minus 2, minus into minus it becomes plus 2. Now in this problem s changes to s plus 2. Therefore we can write L of e raised to minus 2t cos cube 2t, you can write as 1 by 4 3 into s plus 2 divided by s plus 2 whole square plus 2 square plus second term s plus 2 divided by s plus 2 whole square plus 6 square. Now by using the first shifting property, here A is minus 2, minus into minus it become plus 2, s plus 2. Now this is your f of s. Now s changes to s plus 2. This is the second example. Now we will move to the third example. Now what is the third example? Yes, third example is you have to find the Laplace transform of e raised to 3t sin 4t cos 3t. Yes, now here you have to consider e raised to 3t sin 4t cos 3t is equal to e raised to at f of t. Now here function is f of t is sin 4t cos 3t, and what is your a here? E raised to at, a is 3 here, a is 3. Then find as usual Laplace transform for the function f of t, L of f of t, it is sin 4t cos 3t. Now this is also not in the standard form, you have to reduce the given function in the standard form. How you are reducing into standard form? As I told, by using the, this is a trigonometric function, you have to use the corresponding trigonometric formula. It is which form? Sin product, sin A cos B formula. You have to use sin A cos B formula, that is L of 1 by 2 sin of A plus B plus sin of A minus B. This is sin A cos B, that is 1 by 2 sin of A plus B plus sin of A minus B. Now simplify, it is 1 by 2 L of constant, you are taking outside the Laplace transform operator, 1 by 2 is constant. Now it is first term, it is sin 70, 4t plus 3t sin 70, second term plus sin t only, 4t minus 3t, t only, sin t. Now, this given function reduces to the standard form. Now, apply the formula. Which formula you have to use? L of sin 80 formula. What is a divided by? Here it is 7 divided by s square plus 7 square. L of sin 80. What is your formula? A divided by s square plus a square. A is 7. Plus, what about second term? L of sin 80. A is here 1. A divided by s square plus a square. A is here 1. A divided by s square plus a square. Now, this is your f of s. You have written L of f of t as f of s. Now, apply the first shifting property formula. L of e raised to a t, f of t equal to f of s minus a. Now, how will write? This is L of e raised to 3t sin 4t cos 3t. How will write? F of s minus, what is your a here? A is 3. F of s minus 3. Now, this is your f of s. Now, s changes to s minus 3. How will write? Now, this is equal to 1 by 2 into 7 divided by s minus 3 whole square plus 7 square. This is for the first term. How will write for the second term? Plus 1 divided by s minus 3 whole square plus 1. 1 square is 1. Now, this is your required Laplace transform for L of e raised to a t sin 4t cos 3t is 1 by 2 into 7 divided by s minus 3 whole square plus 7 square plus 1 divided by s minus 3 whole square plus 1. Like this, we can do other example. In place of sin and cos, you can change cos 4t sin 3t. You can interchange sin and cos. Again here, you have to use the corresponding trigonometric formula cos a sin b, or it may be cos a cos b, or it may be sin a sin b. Accordingly, you have to use the corresponding trigonometric formula. If it is sin square theta, 1 minus cos 2 theta by 2. If it is cos square theta, 1 plus cos 2 theta by 2. If it is product sin a cos b or cos a sin b, cos a cos b or sin a sin b. If it is sin cube theta or if it is cos cube theta, you have to use the corresponding trigonometric formula. You must know all the trigonometric formula, then only we can reduce the given function into the standard form. That is very important. Then only we can apply the corresponding property formulas. Okay, this is your second property. First shifting property. What is the next third one? Third property is multiplication by t raised to n formula. Third property. What is your first property? First property is linearity property. Second one, first shifting property. Now the third one, multiplication of t raised to n formula. What is this multiplication of t raised to n formula? Now, if L of f of t equal to f of s, L of f of t equal to f of s, now if the function f of t, function f of t, if it is multiplied by t raised to n, it is multiplied by t raised to n. Now, if you take its Laplace transform, what happens? It is minus 1 whole to the power of n d raised to n by d s raised to n of f of s, minus 1 whole to the power of n. See the RHS, minus 1 whole to the power of r n d raised to n by d s raised to n of f of s, where n is 1, 2, 3 and so on. Yes, we can prove this formula by using the mathematical induction, but here n is 1, 2, 3 and so on. You can do this proof of this formula by using the mathematical induction. Yes. Now, based on this property, we will do some of the examples. Yes. Example based on this fourth property. Now, what is the first example? Find the Laplace transform for the following functions. First one, t cos square 2t, t into sin cube 3t, t into cos 4t, cos 3t. Yes, we will do the first one, t into cos square 2t. This is the first example. Now, how to find the Laplace transform? If you consider t cos square 2t is equal to t raised to n f of t. Function is multiplied by t raised to n. Then, what is your function f of t? F of t is cos square t, and what is your n here? T raised to n, n is 1. For the function f of t, you have to find the Laplace transform L of f of t. Again, it is L of cos square 2t only. What is L of cos square 2t? It is cos square L of cos square theta. You have to reduce into the standard form. How you are reducing into the standard form? As I told, cos square theta formula. Cos square theta, what is the formula? Cos square theta 1 plus cos 2 theta by 2. Now, theta is here 2t here, it is 1 plus cos 2 into 2t divided by 2. Now, as usual, constant you have to take outside the operator, Laplace transform operator, and if you simplify 1 plus, it is cos 4t. Now, it reduces to the standard form. Now, what is 1 by 2? What is L of 1? Again, it is L of 1 is 1 by s plus second term L of cos 80 s divided by s square plus a square, s divided by s square plus 4 square. Now, this is your f of s. Now, L of f of t equal to f of s. Now, you can use the formula by using multiplication of t raised to n formula. You have to use the third property, L of L of t raised to n, t raised to n f of t. What is the formula? Minus 1 whole to the power of n, d raised to n of ds raised to n of f of s. Now substitute the corresponding values. Now it is L of t cos square 2t. Now put n equal to 1, it is minus 1 d by ds of, what is your f of s? F of s is 1 by 2, 1 by s plus s divided by s square plus 4 square, you can write it as 16. Now differentiate with respect to s. 1 by 2 is constant, you can take it outside, it becomes minus 1 by 2. D by ds of, it is 1 by s plus s divided by s square plus 16. Now differentiate with respect to s. Now simplify, minus 1 by 2. First you differentiate, 1 by s differentiation, minus 1 by s square plus, what about the second term? You have to use u by v method. Denominator as it is s square plus 16, numerator differentiation, s differentiation is 1, minus numerator as it is, denominator differentiation 2s divided by denominator whole square. Now simplify, this is minus 1 by 2 minus 1 by s square plus, now it is s square plus 16 minus 2s square, it becomes 16 minus s square only, s square, this is minus 2s square, it becomes 16 minus s square divided by s square plus 16 whole square. Now this is the first example by using the multiplication of t raised to n formula. Now we will do the second example. What is the second example? Second example, t into sine cube 3t, t into sine cube 3t. Second example. T into what is sine cube 3t. Yes, now if you consider t into sine cube 3t, that is equal to t raised to n f of t. What is your function? F of t, it is sine cube 3t, and t raised to n is 1 here. Now here you have to find the Laplace transform of f of t. What is f of t? L of sine cube 3t only. Now directly it is not in the standard form. You have to write in the standard form. How you are writing in the standard form? As I told, it is a trigonometric function. It is in the form sine cube theta formula. What is sine cube theta formula? You must remember all trigonometric formula. Sine cube theta formula, 3 sine theta minus sine 3 theta divided by 4. This is the formula. Yes, theta is, what is theta here? Sine cube 3t, sine cube 3t. Now what is theta here? L of theta is 3t, 3 into sine 3t minus sine 3 into 3t whole divided by 4. This is by using sine cube theta. 3 sin theta minus sin 3 theta divided by 4. Now you understood how to convert the given function into the standard form. 1 by 4 is constant, take outside the operator, then L of 3 sin 3t minus sin 9t, 3 into 3, that is 9t. Now it reduces to the standard form. Now apply the corresponding basic Laplace transform formulas, that is 1 by 4 is constant, 3 is also constant. Now L of sin 80, a divided by 3 divided by a square plus a square, a divided by a square plus a square minus again L of sin 80, a divided, a is a 9 divided by a square plus 9 square. Or you can write this 1, 3 into 3, this is a 9, this is also 9, 9 you can take it outside, it become 9 by 4, 1 divided by a square plus 9 minus 1 divided by a square plus 81. Now this is your f of s. Now apply the formula by using multiplication of t raised to n, L of t raised to n f of t equal to minus 1 whole to the power of n d raised to n by ds raised to n of f of s. Now substitute the corresponding values. This is L of t sin cube 3t, that is equal to n is 1 minus 1 d by ds of f of s 9 by 4, 1 divided by s square plus 9 minus 1 divided by s square plus 81. Now 9 by 4 is constant, you can take it outside, multiplied by minus 1, it become minus 9 by 4 d by ds of 1 divided by s square plus 9 minus 1 divided by s square plus 81. Now differentiate with respect to s. What happens? Constant as it is, minus 9 by 4, just simplify minus 9 by 4. Now differentiate with respect to s. What is this? Is if you take into the numerator whole to the power of minus 1, what is 1 by s? Minus 1 by s square, it is minus, and inner derivative, that is 2s s square plus 9 whole square minus it is minus 2s divided by s square plus 81 whole square, and you can take minus sign as common inside, or you can take common, it become plus. 2 is also common, you can take 2 outside, it become 9 by 2, 2 by 4 it is 2, it become s divided by s square plus 9 whole square plus it is minus 1 minus sign, you have taken it outside, minus s divided by s square plus 81 whole square. Now this is your second example by using the multiplication of t raised to n. Now the third example. Now the third example is once again by using the trigonometric function t into cos 4t cos 3t formula. T into, what is third one? Third example, it is t into, what is cos 4t cos 3t. Yes, how to do this problem? just similar to the previous example only. Let t cos 4t cos 3t equal to t raised to n f of t. Then your function is trigonometric function cos 4t cos 3t and t raised to n is 1 only. Now for the given function, f of t, find the Laplace transform cos 4t cos 3t. Now you reduce to the standard form. How you are reducing? By using the trigonometric formula. It is cos A cos B formula. 1 by 2 cos of A plus B plus cos of A minus B. Now 1 by 2 is constant, you can take it outside. 1 by 2 is constant, you can take it outside. Then L of cos 7t plus cos t. Now the given function reduces to the standard form. Now you can apply the basic formula, L of cos at formula. What is L of cos at? S divided by s square plus a square. It is 1 by 2. You have to remember the formula. S divided by s square plus 7 square. S divided by s square plus a square is 7 plus s divided by s square plus 1 square. A is here 1. L of cos at is 1. S divided by s square plus a square. Or you can write 1 by 2. S divided by s square plus 49 plus s divided by s square plus 1. That is equal to your f of s. Now again use the multiplication by t raised to n formula. L of t raised to n equal to f of t equal to minus 1 whole to the power of n d raised to n by ds raised to n of f of s. Now substitute the corresponding value. L of t cos 4t cos 3t equal to RHS n is 1 minus 1 d by ds of f of s. F of s is 1 by 2 into s divided by s square plus 49 plus s divided by s square plus 1. Now 1 by 2 is constant, you can take it outside. 1 by 2 into minus 1, it becomes minus 1 by 2 d by ds of s divided by s square plus 49 plus s divided by s square plus 1. Now differentiate with respect to x by using u by v. How to do it? Minus 1 by 2. 1 by 2 denominator as it is s square plus 49 into s differentiation is 1 minus s as it is denominator differentiation 2s whole divided by s square plus 49 whole square denominator whole square plus similarly the second term s square plus 1 into 1 minus s into 2s divided by s square plus 1 denominator whole square. Now if you do the simplification, 49 minus s square minus 2 s square, 49 s square plus 49 whole square plus second term, it is 1 minus s square divided by s square plus 1 whole square. Now this is the third example by using the multiplication by t raised to n. Now here we did the two property. One is the by first shifting property where the function is multiplied by the exponential function e raised to at, then the function f of s changes to s minus a. Then second one, this is the multiplication of t raised to n formula. When the function f of t is multiplied by t raised to n, then you have to use this multiplication by t raised to n formula. Yes, in the we did two property basically, one is first shifting property, another one is multiplication by 2 raised to n formulas. Now today we will stop here. In the next class we will do the other properties of Laplace transform, that is division by t, periodic function, and also second shifting properties. Thank you.